Hello everyone, myself Dr. Seema from Alobasics. Today we'll discuss AC circuits, which is 13th chapter from Maharashtra State Board Physics syllabus. Today, in 4th lecture of AC circuits, we'll study different types of AC circuits, and particularly in that, we'll discuss about AC circuit containing pure resistor. For studying different types of AC circuits, first of all, we should know that what is AC circuit. And AC circuit are those circuits which are consisting of resistor, inductor, capacitor with alternating voltage. These may be connected with alternating voltage individually or combinedly. Depending on elements in the circuit and their combination, AC circuits are divided into different types, and these types are AC circuit containing resistor, AC circuit containing an inductor, AC circuit containing an capacitor, AC circuit containing resistor, inductor and capacitor in series, as well as we can consider them in parallel also. For our syllabus, we have to study these 4 types. Out of that, in today's lecture, we'll study the AC circuit containing resistor. So let us start with the first type, that is AC circuit containing resistor. From name itself, we can understand that there is a resistor which is connected with an alternating source. This alternating source is having E is equal to E0 sin omega t, that is the alternating EMF which we are going to apply for the resistor. As we are applying alternating EMF to resistor, the current which is flowing through this, that is also alternating, and it is varying its direction constantly. Certain EMF is developed across this R, or in other way I say that instantaneous EMF is present across this R, and this instantaneous EMF is equal to instantaneous potential drop across this resistor. And due to that, the EMF which is present across the resistor, it is given by the amount of current flowing through this into R. According to Ohm's law, we write that potential difference across the resistor is given by I into R. Similarly, here also I say that instantaneous EMF, as instantaneous EMF is equal to instantaneous potential drop, we can write this instantaneous EMF E is equal to instantaneous current I multiplied by R. From these two equations 1 and 2, I can see that their left hand sides are same. So I can equate their right hand sides and I can write IR is equal to E0 sin omega t. So I can be written as E0 upon R sin omega t. हम ये सब क्यों कर रहे हैं? क्योंकि हमें EMF तो पता है. Because of this EMF, how much amount of current is flowing through this circuit, that I want to find out. How the resistor is affecting on the EMF or the current flowing through the circuit, that I want to study here. DC तो हमने स्टडी किया है, पता है, हमने ओम्स लॉ बहुत बार पढ़ा है, यूज किया है. किरचॉफ्स लॉज भी हमने पढ़ाई की है, तो उसमें भी हमने काफी बार हम DC अप्लाइड टू रजिस्टर अप्लाई कर चुके हैं, पढ़ चुके हैं, यूज कर चुके हैं. अब यहाँ पे हमें AC अप्लाई करना है. तो AC क्या इम्पैक्ट देता है, what difference we find in when we are applying DC to resistor and AC to resistor, that we have to study here. That is our main motto of study. So when I'm applying this alternating EMF, for this alternating EMF, how much is current, that I want to find out, and I say that current I is equal to E0 upon R sine omega t. We know that we write this alternating current as I is equal to I0 sine omega t. So, as I is equal to I0 sine omega t, this I0 must be given by I0 is equal to E0 upon R. What it is giving me? Peak value of current is equal to peak value of EMF upon resistance. As this equation, it is similar to Ohm's law. In Ohm's law, what we say that I is equal to V upon R. V is nothing but potential drop. And here I am taking instantaneous EMF is equal to instantaneous potential drop. So what I say that this equation is similar to Ohm's law. And here, if I have IRMS, I can write for that IRMS is equal to ERMS upon R. And as I say that this equation or this equation, both are similar to Ohm's law, we can say behavior of resistor for DC and AC is same. For both I say that current is given by EMF or voltage divided by resistance. If I observe this equation of current and EMF, I can see here both are sine functions. Both are sine functions, both are positive. I will represent the waveform for these sine functions, and here I get a graph of E and I versus omega t for purely resistive circuit. For the purely resistive circuit, first of all, I'll draw EMF. This EMF is represented by E is equal to E0 sine omega t. It is a sine wave starting from 0. Now, current wave is also similar to the EMF wave, and due to that, I'll draw that also, and that is represented in red color. Blue color is representing EMF and red color is representing alternating current across the resistor. Always keep in mind one thing, that amplitude or the peak value of current wave is always less than that of the EMF, peak value of EMF. Or E0E is always having higher value as compared to I0, because I0 is E0 upon R. R is a non-zero, non-negative term. R is greater than 0 always. And due to that, I0 is smaller than E0. So always whenever you want to represent, keep in mind that current wave should have always smaller amplitude or smaller peak value rather than that of the alternating EMF. Now here I am representing their waves, but with that, always it is difficult to represent it in this form. So generally what we do, we use a simple form, that is phasor diagram, which we have studied in our last lecture. So here also I'll draw phasor diagram for this, and phasor diagram for purely resistive circuit is given by, this is representing its EMF E0 sine omega t. This angle is omega t, and we know that it is making an angle omega t with the horizontal. Now as I am representing this as alternating EMF phasor, similarly I want to represent phasor for alternating current. I is equal to I0 sine omega t. Since both are similar, they are varying similar, there is no phase difference between these two. Phase difference is 0 because both are starting at the same point. And here I'll draw for current, it is along the same line, only the length of the current vector is smaller than that of the EMF vector. That we have seen here also. and phasor diagram for EMF and current. They are along the same line. Here we are drawing it on by taking x and y axis, but directly you can draw this along x axis also. Both pure resistive circuit, EMF and current are in phase. There is no phase difference means they are in phase, or zero phase difference means they are in phase. I hope you might have understood when resistor is connected with AC signal how it behaves, and its behavior is similar to DC. Nothing is new in this. Here are the questions on today's topic. Today we have discussed types of AC circuits. Particularly in that, we are focused on AC circuit containing pure resistor. You practice these questions. This theory question, it may help you for exam. Numericals will solve in our further lectures. Thank you for watching. See you soon in the next video of AC circuits.